Today's presentation is going to be on Sqli. We're going to go over a brief overview. We're going to show some example attacks. Designing for Sqli prevention will be touched on. And finally, we'll reach the conclusion section that has my experiences and thoughts that I may have during my research on this. What is Sqli? Well, Sqli is short for Structured Query Language Injection. It is a type of attack that uses SQL. SQL is the language that provides read-write access to a relational database. SQL is the standard language used in today's commercial databases. SQL queries can be sent to a database directly from a web page, or they can be processed by a web server before being sent to the database. Typically, a web page builds a SQL query from a user's input via an HTML form to communicate to the database. So how does an Sqli attack happen? Well, injection happens when a query is sent to the database. The attack modifies the SQL syntax that is sent to a database through a web service call, typically a GET or a POST. While Sqli attacks can be used to attack any SQL database, it is most commonly performed on websites. The query is sent when the user clicks the submit button of an HTML form. HTML forms are used very frequently on websites, so anytime that you go into a website and you got to log in and type in your username and password, that's typically an HTML form with the submit button. The attacks happen because the attackers want to gain unauthorized access to the database. Sometimes the attacker will probe the web page to see if they can get an idea of the structure of the database. The attacker probes the web page by attempting many different injections, and they're looking for an error page or an event to occur, something that's going to give them the structure of the database or give them an idea if their code's even being ran. What are the effects of Sqli? Well, attackers can do all sorts of things if they perform a successful attack. According to the security firm Imperva, these attacks can be highly detrimental to a business's normal operation. Sqli attacks can leave a business's online services unavailable and cause a loss of trust of their customers if their personal information is stolen, such as credit card numbers or addresses. SQL injection attacks can be used to update, delete, or even create new records in a database. Creating records in a database is done via an insert command. Sqli attacks can be used to just retrieve confidential information. As you can see, Sqli attacks can affect the availability, integrity, and confidentiality of the records. What companies have become Sqli victims? In January of 2019, Epic Games fell victim to an attack using a combination of Sqli and XSS, also known as cross-site scripting. We're not really going to get into that here, but those two are normally used in conjunction to attack websites. The attackers were able to gain access of other users and buy in-game items with the user's stored credit card. In January 2019, Lenovo's website was compromised by an outdated product ID that the hackers used to get to an error page, and then built query strings to perform SQL injection attacks. The attack left 1 million users exposed. The attackers also uploaded a dump file containing all of the findings, and it included credit card numbers, IP addresses that were blacklisted, and email exchanges between Lenovo staff and customers. If you want to see any more examples of previous victims of Sqli, you can check out the website at the bottom of the slide. Alright, so to really understand how Sqli works, we've got to understand the basics of SQL. So we're going to go through SQL 101. So bear with me. Data in a database is organized into tables which consist of columns. A table can hold rows of records, and each cell is identified by its column name. Think of it as a big Excel sheet. That's kind of helps me think of it. Let's assume an online retailer such as Amazon stores its user information in a table named user. The user table contains an ID, email, and password column, 3 total columns. The SQL syntax to retrieve all records of their users would look something like this. Select star from user. Syntax to delete the entire user table would be drop table user. So it's drop table and then the table name. Deleting a table will also result in the loss of all stored information in that table. So be careful when you drop tables. Syntax to update a user record: you could change the email to your own, basically giving you access to a user's account. It would be update user, which is the table name, set email, which is one of the columns, equal to anapier@gmail.com, where email equals and then the victim's email address. So effectively, this would find their account in the user table where their email is equal to victim.email@gmail.com, and then it would change it to my email right here. Alright, so we're going to go through a little bit more of the syntax just to kind of get you used to running SQL. Syntax to only select the email from the user table would be select email, which is the column name, from table name, which is user. The syntax to insert a new user record would be insert into, and then in parentheses the columns that you want to give a value for, values, and then another set of parentheses with the actual values. So one is going to be the ID, anapier@gmail.com is going to be the email, and can't crack me is going to be the password. The syntax to select users from the user table by their ID would simply be select star from user, where ID, instead of saying equals 1, we're going to say in and then put some value separated by commas in the parentheses. So this is basically saying where ID equals 1 or 2 or 3 or 4 or 5. It's just shorthand syntax. You can choose to retrieve all columns or only the ones you want to include. The asterisk in the query is used to select all columns. To select only the columns you want, simply list them after the word select separated by commas. Alright, so now that we've kind of went through the basics of SQL and know how it works, we're going to get into some example attacks. Alright, so this type of attack is based on the fact that 1 equals 1 is always true. So suppose a website asks for the user's input of their user ID. The web server will then build a statement including their input for the user ID to the query, or to query the database, sorry. The query might look something like this, here in yellow. As you can see, user ID right here is a variable that gets placed directly into it. This code is dangerous because it sets the variables provided by the user input directly into the query. An attacker could enter 105 or 1 equals 1. This query would then look like all of this, but then instead of saying where user ID equals 105 and stopping, it says or 1 equals 1. And because 1 equals 1 is true, the query will return all rows from the user's table. This is obviously not the behavior that we want. Different attack vector used in SQLi are called batch statements. Batch statements are supported by most SQL databases, and it's basically running multiple queries in succession. So the semicolon is the delimiter in SQL and is used to mark the end of a query. The SQL injection can be performed by using a delimiter to end the statement and start a whole new query that will run right after the first. Another approach to taking advantage of batch statements is using the union operator. The union operator returns a result set of unrelated data, so basically the attacker can write a separate query and append it to the original. Although this still is technically considered only one query, it acts as two. Alright, the attacker chooses to use the drop table operator to delete an entire table, in this case the user table. The query built by the web server looks something like this. Here you can see that they directly insert the vendor ID from the user input. The issue is when the user supplies an input of any number and then a semicolon to end the query and then it inserts their own. So let's say they use 55 as an example vendor ID. Here's what the query would look like with 55 semicolon drop table user. As you can see, the user table will be deleted after this query runs. Alternatively, an attacker could edit the users table by inserting a record so that they may log into the company's website. Their input in that case would be 55 insert into user ID, password, values 9999, and let me in. Example using the union operator. In this example, it's the same query as the last, but let's just say this time they want to steal some confidential information, such as credit card numbers, and assuming that the data is in a table named customers, then the SQL an attacker would input for vendor ID would be an arbitrary integer and then union operator following an SQL query. So the attacker could input 103 union select star from customer, and then the final query would look like this. That query would retrieve all customer records, which include all credit card numbers. This would be a jackpot for a cybercriminal, and clearly not something that you want to just show the world if you're the database admin. Alright, so you got to take caution. These example attacks are highly detrimental to a business's operation, could lead to the leaking of confidential information and the loss of customer data or sales data, or even giving unauthorized access to an attacker. Most businesses now take extra precaution in preventing SQLI, as they now understand how serious the issue can be. There are preventative measures that we can take, and we will review them in the next section. And so here we're going to be designing for SQLI prevention. Fun. Alright, so you got to understand some computer science basics, and it's basically how programs store some data or manipulate data. So programs frequently use a data type called string, and a string object is basically, it can consist of characters and numbers, but you cannot use mathematical, or you cannot perform mathematical operations on strings. You need like an integer or float, double, those type of data types. So strings are built by the web server based off the user input provided, and then those strings are then used as the query to be run against the database. So this picture here is a database schema and just shows a database named library catalog with only one table named checkout. The checkout table is comprised of 6 columns, and this database holds the information for a library to keep track of books that are all checked out. This example is what not to do is Java code that directly inserts the user input into the string query from a web form. The web form has a parameter named checkout number that is passed to the servlet, which is basically a class, a Java class specifically meant to handle HTTP requests. Servlet then builds the query and sends it to the database. Next slide. Here at the top you see the servlet. So basically what's going on here is the checkout number is retrieved from the request, and then here we used the checkout database class to get the information of a checked out book using the checkout number that you supply via input. And then here we're saving the checked out data as a request attribute so we can display that in the browser. Alright, so this one is the database manipulation class. Here you can see this is what happens when a book is checked out. So here we're building the query at the top, and we're directly inserting the checkout number. This is a big no. This is exactly how SQL attacks happen. The librarian website basically pulls up any checked out books. They can search for checked out books by an ID, and so they could run some queries here that could attack the website. It would not be too big of a deal because it's being checked out, or it's being used by the librarians, so not by customers. But obviously if the librarian's attacking the database, then that librarian is not to be trusted. They could ultimately check out a bunch of books and then drop the tables using injection, and then basically have a bunch of free books. Alright, so to prevent all this, parameterized queries can prevent SQL injection attacks most of the time. A parameterized query uses placeholders. In Java, they're question marks. These placeholders are then put back into the query after they're checked for any malicious data. Besides using a prepared statement versus a regular statement, which was used previously, there are other things besides just the protection that is beneficial, such as the performance. Every time you send the query to the web server, it checks for proper syntax, and if it's been sent before, it can avoid doing all the checks. The prepared statement class is always the preferred way to go when accessing a database, and only the prepared statement class reaps these benefits. The statement class does not. Okay, here we use the Java prepared, the prepared statement, which does make use of the parameterized queries. Okay, so here you can see that right here where checkout number equals question mark, that's the placeholder. And then here we actually set that placeholder to the value of the checkout number. And then that's where all the magic happens. It does all these checkings for you to make sure no malicious code is going to be executed. And there's other means of prevention. Probing is done by the attacker basically seeing what they can do to the web server. So the web server admin could review logs, make sure there's not like excessive probing being done. You could also build a blacklist of no malicious queries and compare the final query to be sent. If there are matches, obviously don't execute the query. So finally, we've reached the conclusion section. We're going to go over my experiences and thoughts that I pretty much thought of when I've done my research on this topic. But I'm going to start off with my experience. I do have a bit of experience in working with SQL, as I'm a software tester, and I work with Postgres SQL database every day. I also have experience with Apache Tomcat web servers and using Java to manipulate them. I had written the code presented in this project for an assignment in a different class. I was not required to use the prepared statement, but figured it was a good opportunity to do so. This project has really opened my eyes to the possibilities involved with SQLi. I really like to try and find a vulnerable site just to see SQLi in action. However, I will not do so because I do want to avoid any legal implications. So my thoughts on the research. It's been very informative and fun. I plan to always use prepared statements when I access databases in Java. This brings me to a question though. Why is the statement class not deprecated? This class should just be removed from future Java APIs because it can bring more harm than good to the user. There must be some things I do not understand, and because of my inquisitive nature, I will probably seek more answers. The only good reason I can possibly even think of to keep this Java statement class around is to show developers what not to do and use this class as a teaching tool. However, this is a big risk for companies. Remember, make sure to always validate user input and never directly concatenate the query string with. And here's the references. It was nice dealing with you.